be on page 118 in your book. And we are still working with products today, which means we're still finding the answers to multiplication problems. Now, they have this one, they gave it to you broken out in a distributed a different way. And then you know how they always ask us something that would be too low, too high, and about right. So the first thing I would do, I would just look at my biggest numbers in here. I have 600 and I have a 70. So 600 times 70. I can do quick math on that. 600 times 70. What whole number parts do I see? 7 times 6 is 42. And then how many place values have I not done anything with? 1, 2, 3. Okay, so now if 600 times 70 is 4,200, and then I have some more numbers in there, I know 42,000. I know 42,000 is too low, isn't it? Because I have some other numbers in there with it. Okay? And then if I said, okay, now I'm looking for something too high. 800, because this has a little more stuff in there, and then maybe 80, because there's a little more stuff in that one, and I can do quick math. 8 times 8 is 64, and I have 1, 2, 3 place values that I haven't done anything yet. So I think 64,000 would be too high, because even though I have some more numbers in here, still doesn't quite bump it up to these numbers, does it? And then to get our right. Now I've gone ahead, since we did it on the previous lesson, I went ahead and I made you a partial product box. Okay, and on partial product, remember we just take our number, how it's broken down. This number is actually 645. So if we're using partial product, we would have 645. So we've broken that down into hundreds, tens, and ones. And then on this side, 70 plus 3 is 73. So we broke it down in tens and ones. And then we know we would be multiplying those 2 times each other. So working over here, the first box, 600 times 70. We know that we can do quick math on that. We just did that a minute ago, didn't we? We said 7 times 6 is 42, and the remaining place value multiples of 10. So we already knew that one. So then if we moved on to the next one, 40 times 70. What whole number parts do you see? 7, 4. 7 times 4 is 28. And then we have 1, 2 remaining multiples of 10 placeholders. So we get our 2,800. Oops. Okay, and then we have 5 times 70. But we always place the larger number on top. So 70 times 5, it doesn't change the value. 5 times 7 is 35. And how many remaining place values, multiples of 10? We have 1, so that's where we get the 350. Okay, and then in the next row, we have 600 times 3. If we just look at the whole number parts that we see 3 times 6. 3 times 6 is 18. And we have remaining multiples of 10 place values, 1, 2. So there's where we get our 1,800. Our next box would have been 40 times 3. So if we multiply the whole number parts that we see, 3 times 4 is 12. And how many multiple of 10 place values do we have remaining that we haven't used? We have 1, so that's where we get our 120. And then the last one, we just know that from our math facts. We know that 5 times 3 is 15. Now, if I add all those together, it should give me what goes here, shouldn't it? So I'm going to do, since it is large numbers, I'm going to do the top first. Or could we add this way and then add those three together? Yeah, or we could add these three together and add these three together and then put those together. So there's multiple ways that we can do this. Since they're already stacked under each other, I'll just do them that way. So we have 0 plus 0 is 0. Then move to your tens place. 0 plus 0 is 0. Hundreds place, 0 plus 8 is 8. Thousands place, 2 plus 1 is 3. And then the 10,000s place, the only thing there is a 4. Okay, this next one, drop down just a little bit. In the ones place, we have 0 and 0. In the tens place, we have 0 and 2. In the hundreds place, we have 8 and 1. And in the thousands place, we just have a 2. This one doesn't have anything in the thousands place. And then we'll drop down a little further for this one. In the ones place, we have a 0 and a 5. In the tens place, we have a 5 and a 1. And in the hundreds place, this is the only one that has anything, so we have 365. So now if we add all of these up, 43,800, 2,920, and 365. Okay, let me move these words just a little. Okay, 365. So if we add all that up, 0 plus 0 plus 5 is 5. 0 plus 2 is 2. Plus 6 is 8. 8 plus 9 is 17. Plus 3 is 20. So we'll carry our 2. 2 plus 3 is 5. Plus 2 is 7. And then the only thing in the 10,000s place was our 4. So we have 4,785. Okay? Now, remember that we can double check ourselves by using place values. So let's double check and make sure that that number's correct using place values. So if I go back to my partial product box, in the ones place, I have a 5, 0, 0, 0, 0, 0. So we just have a 5 in the ones place. In the tens place, I have a 1 and a 5, so that makes 6. And then I have a 0, so that's still 6. Then I have a 2, so that's 8. And then a 0 and a 0, so I still have just 8. If I look in the hundreds place, this one doesn't have anything in the hundreds place. But this one I have a 3 and an 8, so that gives me 11. And then I have 1 here, so that gives me 12. And then I have 2 here, so that gives me 14. And then I have 8 here. So 14 plus 8. It's 14 plus 8. 14 plus 8. 12? Is that right? What happened? Where did we go wrong? Gotta keep up with our place values. It's very important that we keep up with our place values. Okay, we know that in the ones place we already counted the 5. In the tens place we have the 1 and the 5 is 6. And then a 0 and a 2 is 8. And then other zeros is still 8. Now, we have to be very careful when we get to our hundreds. We don't have anything here. We have a 3 here and an 8 here. So that's 11. 12. What's wrong here? What's wrong here? Is there anything wrong right there? Do you see where we went wrong a minute ago? we counted this in there with our hundreds, but that's actually in the thousands place, isn't it? So let's take that. Oh, I knew it was going to do that. Sorry guys, just a second. This is 1,800. This was 42,000. Okay. All right, so we're working on that hundreds place. This is a 1. Hang on. I hate when the board erases just a little bit and then you can't get it back just right. Hang on, we'll get it. This is a 3, so this is an 1,800. Okay. When we moved to our hundreds place, we got off on our count a little bit. So we have nothing here. We have 3. And then here we have 8, so that's 11, 12, and a minute ago we counted this 2 in there, but that 2's not in the hundreds place, is it? 0 is there, so we still have 12, and then 8. 12 and 8 is 20. So I would have a 0 here, and then I'm going to put that up there because we're going to carry that over in a minute. And then we look in our thousands place. Well, we don't have anything here or here. We have a 2 here, nothing here, so that's still 2. And then we come over here, thousands place, we have another 2. So we have 4, and then we have 5. We can't forget about the 2 that we carried over there, so that is 7. Okay, and then in our 10,000ths place, the only place that we had anything in the 10,000ths place is right here, and that was a 4. So if we double check ourselves using place value, we see that we still came up with 47,085. It's not going to cooperate today. All right, next page. Okay, now on this one, it says, how are Andre's and Claire's calculations the same? Well, first of all, are they both multiplying 341 times 22? Yeah, they did, didn't they? They both multiplied 341 times 22. Did they both get the same answer? The same product? Yeah, they both got 7,502. What's different then? Oh, look. Andre has 6,000 here, and Claire has it down here. But do they both have it? Yeah. And then Andre has 800 here, and Claire has it here, but they both have it. So if we look at these, if we keep comparing back and forth, then we see that they did the same calculations, they just did them in reverse order. So Andre, when he started his problem, he started immediately working with the tens place and the hundreds place. So he would have had 20 times 300, which is where he got his 6,000. Now Claire did the same thing, she just did it last, didn't she? On Andre's, after he did that, because we know we have to multiply each of these digits times each of these digits, right? But it doesn't matter which order we do it in as long as we get them all. So for this one, if I'm still using this number, this is in the tens place, so I would have 20, and this 4 is in the tens place, so 20 times 40, that's where Andre got the 800. And Claire did it too, she just did it in a different order. On this one, this is in the tens place, so that would be a 20. And this is in the ones place, so that would be your 20 times 1 would give you 20. And then Andre moved to this number. 2 is in the ones place, and 3 is in the hundreds place. So that would be 300 times 2 would give me 600. And Claire did that. She just did it first. Okay? So if we work down that, we see that they both multiplied each digit times the place value of each digit on top, Andre just started with this 2 and worked across. Claire started with this 2. So it doesn't matter. It doesn't matter which way that you go. You're still going to get the same answer. You're still going to get the same product. Now, it says create a list of expressions to match the partial products that Andre and Claire found. Now remember, expressions are just math problems. They're just math sentences. So, an expression, we said, I'll do Andre's on this side. Andre, he got this 6,000 for this partial product because he started with this 2, and it's in the tens place, so that would be a 20. And he started with this 3, and that 3 is in the hundreds place, so that would be 300. That's the expression for how he got that. His next one, he's still using this 2 because he started on this left side. The 2 is still in the tens place, so that's still going to be a 20. And then this time, it's 4 is in the tens place, so that's going to be 40 times 20. So that's where Andre got this number. If we look over here, she started with this one, and there 2 is in the ones place, and the 1 is in the ones place because Claire started on the right and worked her way across. So that would be 2 times 1. So that's an expression for how Claire got 2. Then she moved to the next one. She has 2, that's still in the ones place. And then she multiplied it times this, which is in the tens place, so that would be 40 times 2. So that's where she got the 80. So if we just went down and wrote just a little math problem for each one of these, that's writing expressions. So don't let the term write expressions throw you off. You're just writing the math problem to show how they got that partial product. Okay, next page. Partial products everywhere. Yes, they have partial products everywhere. And it wants us, they've already done the math for us. They've already done the partial products for us. And it just says, take turns picking out expressions that are equivalent to 245 times 35. Well, isn't that 245 times 35? Yeah. And if we're picking out expressions, one expression would be 200 times 30. That's where they got 6,000. The expression for this one would be 200 times 5. That's an expression. This one would be 40 times 30. This one would be 40 times 5. This one would be 5 times 30. And this one would be 5 times 5. So we have written 6 expressions that will equal up to 245 times 35. Now, if we wanted to just write one big expression, what happens if I take this and this and this and this and this and add them all together? I'm going to get that same answer, aren't I? So I would have, if I took 200 times 30 plus 40 times 30 plus 5 times 30 plus 200 times 5 plus 40 times 5 plus 5 times 5. That looks hard, doesn't it? That looks like a hard expression, but you know what? All it is we're just summing them up. So if I just added all of these together, there's my expression. There's a long expression to represent 245 times 35. Okay? And then it says, what is the actual value? All I have to do is add up. So I have 6,000 plus 1,000. I could do quick mental math on that. That's 7,000. Okay. 1,200 plus 200. Again, that's pretty simple to add up. If I have 1,200 and then I get 200 more, I have 1,400. And the last one, 150 plus 25. Well, if I had $1.50 and you gave me 25 cents, I'd have 175. And then I can just add all of these together. So I have 7,000. I have 1,400. And I have 175. So in my ones place, I end up with a 5. In my tens, I end up with a 7. In my hundreds, I have a 4 and a 1, so I end up with a 5. In my thousands, I have a 7 plus a 1, so I end up with an 8. So I'm saying the actual value is 8,575. I can double check that using place values. If I look in the ones place, I have a 5 and a 0 and a 0 and a 0 and a 0 and a 0. So I still just have a 5 in the ones place. In the tens place, I have a 2 and a 5, so that gives me 7. And then a 0, a 0, a 0, a 0. So I just have 7. I go to the hundreds place. This one doesn't have anything. This one is a 1. This one is a 2. So 1 and 2 is 3. Plus 3 is 5. And this is a 0 and a 0, so it's just 5. And then finally my thousands place. This one doesn't have any. This one doesn't. This one has a 1. Doesn't have any. This one has a 6. So 1 and 6 is 7. And this one has a 1. So 7 and 1 is 8. So I still came out with 8,575. So you can always partial product your way. And to double check your final answer, use your place values. And voila, there you go. All right, that is it for today, and I will see you guys tomorrow.